So, yeah, as I said, we are going to be predicting the products in a solution phase reaction, and then use the solubility rules, which are these new little handy dandy rules right here on the back of your periodic table that I just gave you. And then you're going to learn how to write something called the Net Ionic Equation, and then we'll go from there. So there is some important vocabulary that you might want to consider or keep track of. Soluble, insoluble, and something called a precipitate. Soluble is any substance that will dissolve specifically in chemistry in water. So any substance that will dissolve in water. So the state of matter for something that is soluble, especially if it's dissolved in water, would be aqueous. And we'll talk about that a little bit more in a moment. Something that is insoluble would be something that does not dissolve in water. And those two are super important, because if you look at the rules here that I've given you, they say blah, 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 blah are soluble, or they're insoluble, or something along those lines. So make sure that you know what it means to be soluble and or insoluble. And then lastly, the substance, that definition or the term precipitate means when a solid forms when two aqueous reactants are mixed. So a solid that forms when two aqueous solutions are mixed. All right, so those are some basic definitions that we are going to be working off of for the majority of today's lesson. So as we go forward into solution phase reactions, there are some things that we need to kind of go back in time and talk to ourselves about. So at one point, we learned about the different types of chemical reactions, and one of them was the double replacement reaction. And the double replacement reactions are all double replacement reactions are solution phase reactions. And solution phase reactions, basically, we can predict whether or not the reaction will occur based on the solubility rules. So like if you take, I usually give the example, if you take like a bucket of water and you throw a bunch of rocks in it, nothing happens. So we would say, except the rocks get wet, so we would say no reaction. But if you take a bucket of water and you throw some lithium in it, for example, there's a big explosion that happens. And no, I can't do it because it's actually sketchy and dangerous, but there's a big explosion that happens. So there is something that happens. So in solution phase reactions, to refresh your memory, the double replacement reaction was X plus B Y reacts to form AY plus BX. Okay. Now, the new thing that we're going to probably add here is that the state of matter for AX has to be aqueous. And the state of matter for BY also has to be aqueous. But the reaction can occur if one of the products is a solid, say this one, the other one will probably be aqueous. Okay? So if one of the products is soluble, or if one of the products is a solid, the reaction will occur. So if you have two products that are both aqueous, no reaction. If you have a reaction, if you have one of the products being a solid and the other one being aqueous, then the reaction does occur. And that's the important thing that we're going to have to keep track of as we start using our solubility rules on our new periodic table that I just gave you. So there's a couple of other things that we need to talk about. And there's something called spectator ions and the net ionic equation. But what we're really going to do is we're going to use this chemical reaction here to identify whether or not the reaction will occur. Now, I'm told that both of my reactants are aqueous, which means that KCl has been dissolved in water and AgNO3 has been dissolved in water. But I'm not told what my products are. So I have KNO3 and I have AgCl. So everybody grab your handy dandy periodic table and then also grab your solubility rules, which are on the back. So what we've done is we've given you a list of 8 rules that allow you to kind of go through one at a time to decide whether or not a singular product is going to be soluble or insoluble, or if it's going to make a solid or if it's going to be aqueous. So what I usually do is I start at the top of the list and I start with the first substance. So in this case, the substance that I'm going to work off of first is going to be the KNO3. So I'm going to focus on the KNO3 at this point, and I'm going to start reading my rules and comparing them to what KNO3 is. So rule number 1 says salts of ammonium and group 1 metals are always soluble. So do I have ammonia, NH4 plus in KNO3? The answer is no. Do I have a group 1 metal in KNO3? Oh, look, I do. I have potassium. So as a result of that, I don't actually have to go any further. I can just say that this product is going to be aqueous, and it's going to be aqueous because of, and I'm just going to put rule number 1 at the bottom to remind me of where I figured that out. Does that make sense? So now I'm going to focus on the second product, which in this case is the AgCl. So I'm going to start with my solubility rules, and I'm going to start with number 1. Number 1 says salts of ammonium, NH4, and group 1 are always soluble. Is Ag a group 1 metal? All the group 1 metals are lithium, sodium, potassium, rubidium, cesium, and francium, so the answer is no. So rule number 1 does not apply. Rule number 2 says halides. All chlorides, bromides, and iodides are soluble except if they're paired up with silver, mercury, or lead. So I have a chloride, Cl, right? And I want to believe that it is soluble because all chlorides are soluble except if they're paired with silver. And Ag is silver, so that makes this a solid because of rule number 2, and I'm going to put 2a, but rule number 2 is fine. So in this instance, this reaction does occur. So I'm going to write that. The reaction occurs. Yay. Okay. Now, the other thing that we need to know about double replacement reactions is that the formation of solid, so in this case, the making of silver chloride, AgCl, is what drives the reaction that makes the reaction occur. So you know how like sometimes, so you remember like in middle school or elementary school, there was like a fight, or even in high school, there was like a fight, you know what I'm talking about? And like as you're walking down the hallway, there's going to be payback for said fight, like days later. So like you got into a fight and you're walking with your BFF, right? And your BFF sees the person you got into a fight with down the hall, right? So as you're walking down there, you're in your head going, "Oh man, I just got back from suspension. I didn't get a ticket. I gotta mind my P's and Q's," and you're trying to like do all the right things. But your buddy's like, "Hey, there he is. Let's go get him." And you're like, "No." He's like, "No, you can't let him treat you like that." And you're like, "No." But as you get closer and closer, your buddy has egged you on and brought you to the fight. But then when you get there, you know what happens? You get into a fight and your buddy goes like this. Am I right? So what is your buddy actually doing at this fight? Is he participating or is he spectating? The answer is he's spectating, right? So if he's spectating, he is a spectator ion. So he's necessary for the reaction to occur, but doesn't actually do anything. So in this reaction, the ions that are present, and I'm going to list them all real quick right once. So I have K, which is a +1. I have Cl, which is a -1. I have silver, which is a +1. And I have nitrate, which is a -1. Okay? Now, those are all four of the potential ions that are present, right? They're there at the beginning, they're there at the end. But the issue is that the Ag and the Cl, right? So I'm going to circle those, and I guess. So I'm going to circle those. The Ag and the Cl make a solid, right? They make AgCl, solid. So that means that my other ions that are present are watching. Are K and NO3. They're just watching this happen. They're like when somebody in the comment feed on like Reddit or whatever, and people are like going off, and you're just there for the comments. You know what I'm talking about? You're there eating popcorn. Isn't that great? Anyway, so now at this point, what's really happened is I now have the ability to write what actually happens in this reaction. So this is going to get a little bit cumbersome for the first one, and then after that, we'll kind of back it off. So if I know that I have K, which is a +1, and it's aqueous, and I have Cl, which is a -1, and it's also aqueous, and I have Ag, which is a +1, and it's aqueous, and I have NO3, which is a -1, and it's aqueous. But over here on the product side, K is still aqueous, and NO3 is still aqueous. But AgCl is a solid. When I write the net ionic equation, I only have to record what ions were present at the beginning that made the solid at the end. What two guys were about to fight that got into the fight at the end. So when I look at this, I know, based on what I've already written and seen above, that the Cl, which was aqueous, and the silver, which was also aqueous, react to form the Ag and the Cl, which ended up being a solid. So this is what's called the net ionic equation. The ions that form the solid are the net ionic equation. So I went through the process and identified my spectator ions, and I wrote every ion out. And then in theory, what I could do is I guess I could cross out the K and I could cross out the NO3 because they're spectator ions. And like that might be a practice that we actually use. But for the time being, I just want you to know that what you're trying to come up with is the actual equation for the actual reaction. Questions? All right. So we have another example, okay? And in this case, remember, we have to predict our products first. So if this is a double replacement reaction, which all of the ones on the worksheet that we're going to have today are, right? We are going to do the old-fashioned switcheroo, and I can't remember what I call it. All right, so in this case, I have A, and I have X, and I have B, and I have Y, and then we're going to do the old-fashioned switcheroo. So I have, let's see, A, which is here, and Y, which is here, and then I have B, which is here, and then X, which will be here. So what I'm going to do is I'm going to just line things up like we did once upon a time, what feels like forever ago. And I'm going to put my sodium here. I'm going to put my phosphate way back over here. I'm going to put my calcium here. And I'm going to put my chlorine here. Oops, wrong color. Okay. Now, what I really have to remember is that I have to check my charges and crisscross them down. So going back to your periodic table, on the top of your periodic table, on the top of those columns are charges for every single element on the periodic table. Well, the easy ones anyway. So I know that sodium is in the first column, so it is a charge of 1 plus 1. And I know that chloride is in the 17th column, and it has a charge of -1. So the ratio here, when I crisscross those charges down, is NaCl 1:1. So far, so good. However, with calcium is in the second column, so I know that it has a charge of +2. And phosphate is in no column, but I know it is a polyatomic ion on the back, and it is a charge of -3. So when I crisscross those charges down, I get Ca3PO4 2. Oh man, that's a solid review of predicting products. Now, so that's step 1, predict products, right? 1, predict products. Step 2. Step 2 is use solubility rules. So I'm going to start with solubility rule number 1, and I'm going to focus on the first compound here. So I'm going to focus on this guy right here. Solubility number 1 says all salts of ammonium, NH4 plus 1, and group 1 metals are soluble. So let's see. Sodium is a metal, and it happens to be in the first column. So that means it's soluble. So this is aqueous because of rule number 1. All right. Now I need to go on to my next reaction, or my next product, which in this case is calcium Ca3PO4 2. So I'm going to start with rule number 1 that says all salts of ammonium, NH4 plus 1, and group 1 metals are soluble. Calcium is a group 2 metal, so that does not apply. Rule number 2 says all chlorides, bromides, and iodides are soluble. Well, in Ca3PO4 there are no chlorides, bromides, or iodides, so that rule doesn't count. Rule number 3 says chlorates, nitrates, and acetates are soluble. And I give you what those are. And PO4 is not a chlorate, it is not a nitrate, it is not an acetate, so that doesn't apply either. Sulfates are soluble, SO4. Nope, no, there's no sulfate present. Phosphates and carbonates are insoluble except those of ammonium and group 1 ions. So in this case, phosphate, yep, PO4, is insoluble, should make a solid, except if it's paired up with ammonium, NH4, or a group 1 metal, which is lithium, sodium, potassium, rubidium, cesium, francium. And it's not, so that means that it is going to be a solid because of rule number 5. Step 2. Woohoo! So this reaction occurs, all right? And as a result of this reaction occurring, I now have to come up with what the spectator ions are going to be and the net ionic equation. So I'm sitting here, I'm looking at this, I've done a lot of work already. I can tell that, I guess I'm going to write one more out and then we'll just kind of go from there. Oh, wait, we didn't balance. We might as well balance this because it works. So I got to do that. So now, all right, going from left to right, I see that I have 3 sodiums and 1 sodium. And if I put a 3 in there, that'll give me, but I see that my chlorides are messed up. I'm going to make this balance real fast like. So let's see. I'm going to throw a 6 here. I'm going to drop a deuce here. And then I'm going to put a 3 here. And then everybody's happy. So far, so good. Whew. So now I got to figure out what my spectator ions are, and I have to write my net ionic equation. And the easiest way for me to do that, for me anyway, is to write all of the ions out and then figure it out. So I know that I have, because this 2 distributes itself like so, I have 6 sodiums, and I have 2 phosphates. And I have 3 calciums, and I have 6 chlorides. Okay, now these are all aqueous because they're dissolved. And on my product side, I have 6 sodiums, which is aqueous, and 6 chlorides, which is also aqueous. And I have, for sake of balancing, 1 Ca3PO42. And that is a solid. So the ions that make the reaction occur, the ions that make the solid are the calcium and the phosphate. So when I write my net ionic equation, I'm only going to write the ions that make the solid. So in this case, the ions that make the solid are the 2 phosphate ions, which originally are aqueous, and the 3 calcium ions, which are also aqueous, and they form the solid, which is Ca3PO42. And the last thing I have to do is identify spectator ions. And those are the ones that are simply left over. So my spectator ions, I'm going to cross out up here in my original equation. And I'm going to simply identify them as, let's see, sodium and chloride. So it seems like a lot of work, and I'm showing a lot of steps. And at some point, you can this will get quicker for you. But for the time being, that is what we have to do. Okay. Questions? Oh, the question is, how do I know if it's in group 1 or group 2? Okay. So when I'm looking at, so when I see that, like, for example, salts, rule number 1 says salts of ammonium are group 1 and always soluble. I just flip over my periodic table, and anything in column 1 is group 1, right? Anything in column 2 is group 2. So when I'm looking at, for example, Na for NaCl, Na happens to be right here, and it's in group 1. However, calcium, right, happens to not be in group 1, and I located it's in group 2, and so that's how I figure that out. Okay, that was a pretty good question there. Hopefully that was a pretty good answer. All right, moving on. So we have to do this again. There's so many examples. Let's try to do one more here, at least. Okay, so I have Na, and I'm going to kind of switch that to over here. And I have NO3. So I'm going to put that way over here. And I have Li, which I'm going to put near NO3. And I have Br, because we're doing the old switcheroo, which I'm going to put here. Okay. Now, before I go much further, I'm going to go ahead and identify my I'm going to check my charges and cross them down, right? I see that sodium is a +1, and I see that bromide, because it's in group 17, is a -1. I see that lithium is a +1, and I see that nitrate, when I flip it over on the back of my periodic table, right, is a -1. Okay, so this happens to be balanced the way that it is, and it nicely works out the way that it is. Now I have to go ahead and identify whether or not it's soluble. So again, I'm going to start at the top of my rules, right? So in the case of the first one, I'm going to start with rule number 1. So I'm focusing right here. Rule number 1 says salts of ammonium, NH4, and group 1 metals are always soluble, right? Well, NH4 is not present, but I do see Na, which is right here, which happens to be a group 1 metal. So that means it's soluble. So that means it's aqueous. So I don't have to worry about that one. Now I'm going to worry about this one over here. And I'm going to start at the top with rule number 1 again. And rule number 1 again says salts of ammonium and group 1 metals are soluble. So I see Li, and I flip over my periodic table, and I see Li happens to be a group 1 metal. So as a result of that, that's also going to be soluble. So both of these are soluble because of rule number 1, and that's all the work that I had to do. So what this tells me is that there's no solid forming, so no reaction. And that's it. You're done. Yay. All right. Let's see. Something to check on real quick. I want to check on this real quick. Okay. All right. So here's where we're at. I'm going to finish up this last example on here. But your homework is to work on the worksheet in the packet. It has 1, 2, 3, 4, 5, 6 problems on it right here. Okay. You are predicting the products, identifying whether or not the reaction will occur. You are checking solubility rules. You're doing all of the things. Okay. I'm going to finish up this last reaction here. So just quietly pay attention. And if the bell rings, have a good weekend. But that's your homework over the weekend. And I'm going to finish this up for the video people at home. So in this case, I have copper and I have sulfate. And I have lithium. And I have hydroxide. So I'm going to switch those around. So I see that I have copper, and sulfate would be the other product, SO4. And I have lithium, which will go with the sulfate. And I have hydroxide, which will eventually go with the copper over here. Now, I need to check my charges. And copper is a transition metal. So I have to uncriss-cross that, okay? Oh boy, so there's some work I have to do. So I need to figure this out, okay? I see that the ratio for copper to sulfate is 1 to 1, which makes me want to believe that copper is going to be a +1. But if I locate on the periodic table, not on the periodic table, on the polyatomic ion list, sulfate is a -2. So sulfate has a charge of -2. And in order for copper sulfate to be 1 to 1, that would mean that the ratio is at some point 2 to 2, which means that copper has to be a +2. Okay? So that means that copper over on this side is also a +2. And since we've already figured out what sulfate is a -2. Now, hydroxide is on the polyatomic ion list. It's over here. It happens to be a -1. Oops, you see it right there? OH happens to be a -1. So hydroxide is a -1. And lithium is a group 1 metal, so it is a +1. So I'm going to crisscross my charges down, just like we've done in the past, and I'm going to get CuOH parentheses 2, and I'm going to get Li SO4 2. And so now I've got my reaction, and I'm going to take the time to identify whether or not this reaction will occur by checking my solubility rules. So I'm going to start at the top. Rule number 1, salts of ammonium, NH4 plus, and group 1 metal are always soluble. Copper is not a group 1 metal or ammonium, so it's not soluble. So rule number 1 does not apply. Rule number 2 says all chlorides, bromides, and iodides are soluble, and there's no chloride, bromide, or iodide present. So I'm going to move on. Chlorates, nitrates, and acetates are soluble for rule number 3, and none of those are present. Sulfates, that's not present in the first compound. Phosphates, carbonates, and ammonium none of those are present. Metallic hydroxides or oxides, rule number 6, those aren't present. Metallic hydroxides are present. So in this case, rule number 7 says all metallic hydroxides are insoluble except if they're paired with ammonium, group 1, or group 2 from calcium down. And since copper is none of those, that makes this my solid, and it's my solid because of rule number 7. I do want to take the time, though, to check on this one real quick because I want to make sure that I have practiced my rules properly. So I'm going to start back with rule number 1. Salts of ammonium and group 1 are always soluble. Lithium is a group 1 metal, so it does fall in this category. So because of rule number 1, this is going to be aqueous. All right. So at this point, the next thing that I should probably do is balance my equation. So I'm going to do that. I see that I have 1 copper and 1 copper, 1 sulfate and 1 sulfate, 2 hydroxides. So I'm going to put so that it balances like so. Now the next thing I'm going to do is I'm going to go ahead and figure out my spectator and my spectator ions and my ion and the ions that drive the reaction are, and I'm going to start by writing out the entire equation. So I have copper, which is a +2, and it's aqueous at the beginning. And I have sulfate, which is a -2, and it is aqueous at the beginning. And I have lithium. And again, the lithium, the coefficient of 2 in front of lithium distributes it out. So I have 2 lithiums, which are +1, and they're aqueous at the beginning. And I have 2 hydroxides because that 2 also distributes itself to hydroxide. they're -1, and they're aqueous at the beginning as well. My solid comes next, so I'm just going to write it as it is. I'm going to keep it together, Cu OH2, and leave it as a solid. I'm going to make that. And then my last elements are lithium and sulfate. Now, I see that there's a subscript of 2, so that kind of tells me that I have 2 lithiums. So I have to apply that here. So 2 lithiums plus 1, which are aqueous, and the sulfate, which is -2 or 2-, which is also aqueous. So again, the ions that drive the chemical reaction are the ones that form the solid. So the ones that don't form the solid in this case are my spectator ions, and I'm going to just kind of cancel those out. They're the ones that are aqueous on both sides. So aqueous, 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 aqueous. So my spectator ions I've identified, so now I just need to rewrite the reaction so I have my net ionic equation. So it's copper, which is +2, and aqueous, reacts with 2 hydroxides, which is -1, and aqueous, to produce the copper hydroxide, which is my solid. So this is my net ionic equation. And my spectator ions are the ions that I crossed out. And so I need to simply just identify them, and those would be sulfate and lithium. And so that wraps up the lesson here. That's the final example. And again, your homework practice is going to be the second worksheet in the packet, which looks a little bit like this. It says worksheet for number 2, solution phase reactions, and you have 6 problems where I ask you to write the net ionic equation and then identify the spectator ions. And we will be going over that Monday. If you have any questions, please let me know. Other than that, have a good day.